Riverbend Transfer Systems Hose and Hose Technology, or HIHTL, has been used to successfully transfer high-level radioactive waste at various national and international nuclear facilities since 1999. In 1998, a 1 million gallon underground storage tank designated SY-101, located at the Hanford nuclear site, experienced a continuous unexplained level rise. This tank was previously listed as the #1 safety issue in the DOE complex due to its episodic releases of highly flammable hydrogen gas and violent events known as burps. In order to prevent the level from exceeding regulatory limits, a team was formed and authorized to emergency pump the tank. Due to restrictions on the weight that the tank dome could support, authorization was also received to use an above-ground transfer system. Riverbend Transfer Systems supplied a design to meet the stringent requirements specified. The team was successful in resolving the level rise issue and ultimately returned the tank to operational status. A post-project review identified significant benefits of the HIHTL design, rendering traditional pipe-in-pipe systems obsolete for many applications. Basic HIHTL systems are comprised of three components: a primary hose or hoses sized according to system needs, a larger encasement hose designed to meet regulatory requirements in the unlikely event of a breached primary hose, and the necessary patented fittings to mate hose assemblies to each other or to facility connections. Additional equipment can be installed, such as leak detection, heat trace, thermocouples, or shielding to provide reduced area dose rates. The inner lining of the primary hose can be selected to accommodate the specific chemical properties of the fluid to be transferred. HIHTLs offer significant advantages over other materials and designs. They are easily routed inside facilities, around equipment, or across open terrain. If procured and staged for emergencies, they provide near real-time response capability. Assemblies can be manufactured, delivered, and installed in as little as 8 weeks, depending on hose lengths and site requirements. Inherent flexibility of a hose provides significant protection and survivability from seismic events. This was a critical attribute for deployment at the Fukushima nuclear plant. Materials used in manufacturing of the assemblies result in a robust product that is resistant to chemical, radiation, and environmental exposures. Minimal engineering is required for installation, and assemblies are routinely installed at or just below grade, minimizing or eliminating excavation. The combined attributes of the HIHTL technology result in a significant savings in time and cost when compared to equivalent hard pipe systems. While each assembly is designed and built to meet a specific customer design, the modular nature of the assemblies provides capability for them to be adapted or reused in multiple configurations. A typical HIHTL design is rated for 425 pounds per square inch and 180 degrees Fahrenheit for the primary transfer line. HIHTLs have been used to transfer fluids and slurries with solid loadings up to 30%. The EPDM rubber is extremely resistant to radiation damage and is rated for 10 million rads cumulative dose. Experience has shown that flushing prior to decommissioning and after pumping campaigns results in extremely low contact dose rates, often less than 5 millirem per hour. HIHTL assemblies are specially constructed to Riverbend Transfer System specifications by Vayance Technologies, formerly known as Goodyear Engineered Products. Both primary and encasement hoses are comprised of several layers of EPDM synthetic rubber and a combination of steel wire and synthetic fabric for reinforcement. The EPDM resists degradation from chemicals and radiation and provides a low coefficient of friction. The interior tube, which contacts the waste, can be custom selected from several materials to accommodate specific waste types. Stainless steel end fittings are attached to the hoses using patented technologies and can be manufactured to mate with any facility-specific connection. To meet the design specifications for use in the Hanford tank farms, several tests were required to demonstrate the robust nature of the HIHTL assemblies. Steel plating is often used for shielding, and an accident scenario of a drop plate was postulated. a requirement was developed that a drop plate could not result in catastrophic failure of an HIHTL. A test apparatus was constructed to drop a 4-foot by 10-foot, 2-inch thick steel plate from a height of 6 feet onto HIHTL assemblies. The drop was repeated 20 times on each test assembly. Additional test assemblies were repeatedly crushed by crane outriggers and driven over by a crane. Each of these 3 tests subjected 5 test assemblies to potential damage. All 15 assemblies were then subjected to the acceptance test for new hoses. All test assemblies passed burst pressure and tensile strength test requirements. The unique advantages of HIHTL technologies have led to its use in several applications by numerous companies around the world. It has been used at 3 Department of Energy sites in the U.S., as well as for emergency response at the Fukushima nuclear plant in Japan. There, HIHTL technologies are in service to transfer cooling water from the stricken reactor facilities to a water treatment plant, which removes extremely high levels of radioactive contaminants. The most recent HIHTLs were procured by Areva to provide emergency waste transfer capability at the Le Hague facility in France. Volumes of waste transferred are significant, as are the lengths and numbers of systems installed. A total of over 10 million gallons has been pumped through over 11 miles of HIHTL assemblies, with significant savings in materials, design, and installation costs being realized by the users. Riverbend Transfer Systems continually works to develop innovative and improved products to meet industry needs. Development efforts have led to the iHose, or intelligent hose. Though extremely unlikely, any leakage through the inner tube of a primary hose of the iHose is immediately detected, allowing a controlled response before the containment capability of the primary outer hose casing can be challenged. This design is undergoing testing. These photographs provide examples of the different installation HIHTLs have been used in. They include DOE sites where they have been used over 13 years to emergency pump tanks, retrieve waste for treatment, and provide cost-efficient transfer routes to replace aged and leaking direct buried steel transfer piping. Because of the ease and the speed of installation, HIHTLs were chosen to transfer waste at the Fukushima nuclear plant. Its advantages provided the quickest response to the accident and met the detailed specifications the plant demanded. Areva's experienced gain with the HIHTL system design and installation in the DOE complex led to its selection for emergency transfer contingency at its Le Hague facility. Though originally designed for use in waste transfer systems, HIHTL is now seen as a cost-effective option where high reliability, ease of installation, quick response, and leak containment are necessary attributes. An example of an HIHTL installation across open terrain is provided in this photograph. This aerial view shows an 1,800-foot HIHTL installed between 2 of Hanford's underground tank farms. The installation of the HIHTL was completed in less than 5 days, with the concrete shielding adding another 3 days of installation time. Site preparation consisted of grading the root level and installation of 2 vehicle accesses. The ability to be routed around and through existing infrastructure, as seen here, reduces design and installation costs, as well as minimizing impacts on operations. Riverbend Transfer Systems has designed and installed several types of shielding depending on the application and customer needs. This shielding can be installed quickly for vehicle drive-overs, physical protection from potential hazards, and lowers doses to workers who may be in the vicinity of an HIHTL route. Typical shielding materials are concrete, steel, and lead. For more information, orders, or technical assistance, please contact Jeff Barnes of Riverbend Transfer Systems.